Hi everyone, welcome back. Let's continue with session 11.9. The last topic we want to talk about is the circle and the radius of curvature. Choose a point P on a smooth curve C in the plane. The circle of curvature, or osculating circle, at the point P is the circle that is tangent to the curve at point P. And it has the same curvature as the curve at P. It lies on the same side of C as the principal unit normal vector n. So this is the picture. We have the C, okay? And then the oscillating circle lines on the same side of C, and you can see the center and the point. The center is on the right in the direction of the principal unit normal vector. Okay, and furthermore, the center, the oscillating circle and the curve have the same curvature at that point. Okay, the radius of the curvature is the radius of the circle of curvature. The radius of the curvature is equal to 1 over kappa, okay, where kappa is the curvature of the curve at P. So do you remember in our first video when we talk about curvature, we have a circle with radius r, then the curvature equals 1 over r. So this is the same thing. We have this circle, then the radius is going to be 1 over the curvature. Okay? And let me show you more picture. So if you go to our course website, you see this session with 3, the oscillating circle, click that link, and then you see this website. You can see at each point, it shows us an oscillating circle. Okay? And it's always on the same side as the curve, okay, pointing to the principal unit normal vector. Okay, the center is always on the principal unit normal vector, and you can play with it. Here, the restriction is this is only for the xy plane, okay? But I'm sure in the 3-dimensional you're able to construct it. So you can change the function to be, let's say, x. Oh, you know x was the curvature for a line. Well, the curvature for a line is 0. Okay, the direction won't change. The curve is not turning, so that's why you don't see any oscillating circle. But how about the parabola x squared? You see? Okay. You see how the oscillating circle change? Okay, it's bigger, smaller, and then once it reaches the origin, it gets the smallest. Because you can see if the curvature is big, the curve turns quickly, then the oscillating circle is small. If the curvature is small, it turns slowly, then the oscillating circle is large. Okay. How about let's see, if we change to x cubed, what happened? See? Ooh, you see it flip around, it turns. Okay, it was on like one side of the curve, and then it flips around and go to the other side of the curve. Okay, and this is what happens when the curve turns from left to right or from right to left. Alright, so you can play with this website and you can input more functions. How about e to the x? We haven't seen it. Okay. See, it's actually smaller near the origin. When it go away from the origin, the oscillating circle is gonna be bigger. Okay, so let's come back. Okay, so let me just copy down what I said. Okay, so if the curve turns quickly, so the curve turns quickly, then we have a large curvature and then small circle. Okay, so the circle gonna have smaller radius. If the curve turns slowly, then we have a small curvature, but we have a large circle. Okay, let's look at the following example. Find the radius of curvature of the cycloid. Gamma of t is t minus sine t, 1 minus cosine t, at t equals pi. Find the equation of the circle of curvature at the point. Okay, so in this problem, we not only find the radius, we know radius is 1 over curvature, so we need to find the curvature, but because we also need to know the equation of the circle, okay, of the curvature at that point. So we need more information. Let's see, let's find the velocity. Velocity is the derivative of the displacement. Derivative of t is 1. Derivative of sine is cosine t. Derivative of 1 is 0. Derivative of cosine is negative sine. So negative become positive sine t. And then what is the magnitude of the tangent vector? Okay, so we have square root of 1 minus cosine t squared plus sine t squared. Well, oh, my line is too long. Okay, so what is that? Well, we multiply out 1 minus cosine t plus cosine t squared plus sine t squared. Ooh, what is that? You know, cosine plus sine is 1. This is the same as 2 minus 2 cosine t. And do you know what that is? Well, it'd be great if we can simplify it, right? So here, think about the double angle formula. So what is double angle formula? Cosine theta squared is 1/2 plus 1/2 cosine theta. Sine theta squared is 1/2 minus 1/2 cosine, 2 theta. Here it looks like this guy, right? So we multiply by 4 on both sides, and we let theta be t over 2, right? Then this guy is 4 sine squared of t over 2. Well, because we're interested when t equals pi, so you know sine looks like this. So t over 2 with pi over 2 is here. So pi over 2 is here, then sine is positive near pi, near that point, right? So that's why square root of 4 is 2, and then square root of sine squared is absolute value of sine t over 2, but because the sine is positive near that point, so we can get rid of the absolute value. So we can simplify it. Then what is the unit tangent vector? Okay, unit tangent vector equals the v over speed, right? So we have 1 minus cosine t over 2 sine t over 2, and then we have sine t over 2 sine t over 2. Okay, do you know what that is? Okay, what is 1 minus cosine t? Well, use the double angle formula again. But now we multiply by 2. So we have 2 sine theta squared is 1 minus cosine 2 theta. Now you let t be 2 theta, then theta equals t over 2. So this is the same as 2 sine t over 2 squared over 2 sine t over 2. And what is sine 2 theta? This is 2 sine theta cosine theta. So sine t is then 2 sine t over 2 times cosine t over 2. See, we can simplify it. So we can simplify, and here 2 cancel, 1 copy of the sine cancel, 2 sine cancel. So we have sine t over 2 and the cosine t over 2. You might say, wow, why do we want to calculate t? Okay, because here, in order to get the equation of the oscillating circle, not only we need to know the curvature, but also we need to know the principled unit normal vector. And in order to know the principal unit normal vector, we use t prime over the magnitude of t prime. So once we find t, we can then find t prime. So the derivative of it is, for chain rule, 1/2. Derivative of sine is cosine. And then chain rule, derivative of cosine is minus sine. So here, if you don't use the double angle formula and simplify the answer, when you do you want to take the derivative of this guy? That's quotient rule and it's so complicated. So please simplify before we differentiate. Now, what is t prime? Well, square root of 1/2 squared cosine t over 2 squared plus 1/2 squared sine t over 2 squared. But you know, sine squared plus cosine squared, no matter what the angle is, it's just 1. So that's why here we just get 1/2, 1 over like 2 square roots, so it's half. Okay, so our n is t prime over the magnitude of it. Oh, you can see when we divide it by 1/2, these guys gone. Then we only left with cosine t over 2 and negative sine t over 2. So much nicer quantity, right? And then we also need to find the curvature. So how do we find the curvature? Well, we can use the equation, the magnitude of the t prime over the speed. So that is 1/2. What is the speed? Speed is 2 sine t over 2. So you can see that's 1 over 4 sine t over 2. Okay, and this is the curvature. Now, what is the radius of the oscillating circle? 1 over curvature. So that's 4 sine t over 2. So far, so good, everybody? All right, let's continue. So at the point t equals pi, what is the radius? Sine pi over 2 is 1. So the radius is 4. Okay, how about the point? Well, the point is gamma of pi. So t minus sine t, 1 minus cosine t. So that the point, okay, is gamma of pi. Pi minus sine pi, 1 minus cosine pi. So sine pi is 0. Cosine pi is minus 1. 1 minus 1 is 2. Okay, so what does that mean? Okay, we also need to know, okay, what is the principal's unit normal vector? Well, this is cosine of pi over 2 minus sine pi over 2. Cosine pi over 2 is 0. Sine pi over 2 is 1. Okay, so this is the principal's unit normal vector. And then let's begin to draw, and let's figure out the relationship between them. So we have the points at pi 2. So 2 here, pi here. This is the point. And the principal's unit normal vector is 0 minus 1. So 0 minus 1, like that. Okay, so this is n. What does that mean? It means your curve look like this. Okay, now how do we find the oscillating circle? Okay, so we know the radius, right? The radius is 4 and is in the direction of the principal's unit normal vector. So it's in this direction, right? It's going down, and it's going down 4 units. Well, this guy is 2, so we go down 4 units. We will arrive, what can you say about this point? It will be pi and negative 2. Well, this guy is gonna be the center of the oscillating circle, because the oscillating circle will look like this. Can you imagine, everybody? So now we know the oscillating circle. Okay, oscillating circle with the center is pi negative 2 with the radius is 4. Okay, radius I use rho to denote, okay, but you know that's the radius. Then we can form the circle equation, right? X minus the x coordinate of the center, pi square, y minus the y coordinate. So y minus negative 2 is the same as y plus 2 squared, plus the radius square. So 4 squared is 16. Okay, so this is the equation of the oscillating circle. So in this problem, it is easy because our principal's unit normal vector is pointing down. So we have the x coordinates to the pi, and then the y coordinate we just have 2 minus 4. It's minus 2. What happened? Okay, so we mark here. So what happened if our n is like, it's not like vertical going down? Okay, so in general, if n equals, let's say n1, n2, okay, then let's say if our p is here, okay, in general, if our p is here, okay, and our n is here, how do you find the center? How do you find the center? Okay, let's say the center is C or Q. Let's use Q because C looks like the curve. And how do you find the center? You can see here, let's say here is the origin O, okay? You know OP plus in the direction of n, so but you want to have the radius is rho, okay? So rho times n. Okay, so this guy is gonna be OQ. Okay, so this is how you find the center. Okay, the center OQ is gonna be OP, your original point, plus rho. Rho is the radius, okay, times the principal's unit normal vector. Okay, and you can check here. So you can check in our example. Our point P is pi 2, and then plus we have the rho is 4 times 0 minus 1, and you can see the x-coordinate it won't change, so it's still pi, but the y-coordinate 2 minus 4 times -1, so sorry, 2 plus 4 times -1 is the same as 2 minus 4, so we get -2. Okay, so far so good, everybody. Okay, now with this remark, then in general, any normal vector, then you can use this trick to find the center. Once you know the center, you know the radius, then you can write down the equation of the circle. Okay, so that is session 11.9. I know this is a long session, okay? So now you can go ahead and complete the homework. And don't forget, if you have any questions, feel free to print screen your questions and ask me either in class or office hours or email, okay? Have a nice day. Bye.